Y25 photon. In the previous class, we learned that the full momentum consists of 4 components, and the first component is E over C, and the spatial component is P, and P is mass times velocity. And mass times velocity means derivative with respect to time. That is, this time is gamma tau. And mass is rest mass divided by a strange factor called the Lorentz factor. And energy equals mc squared, or here mass is m0 rest mass divided by this multiplied by Lorentz factor. And this relation gives an unshell condition. Unshell means on its mass shell. The reason why we use this shell is it is a kind of sphere. For example, it is x, it is y, then it looks like x squared plus y squared equals r squared. Okay? Something like that. So shell is a surface of a sphere. And if we cut it into 2 dimensions, it becomes a circle, and it is like a circle. That x squared plus y squared equals r squared. Instead, this circle usually we use constant radius. However, it is not constant, but this one is constant. That's the reason why this square subtracted by square equals m0c squared. If we divide both sides with the m0c squared, it is something like square subtracted by square equals 1. This is a hyperbolic equation. This is an equation of circle, and this is equation of ellipse, and this is an equation for hyperbola, right? So the space, Minkowski space, is a hyperbolic space. Anyway, it looks like a trick, but now we learn explicit experimental evidence of this strange formula. That is the consequence that speed of light c is a constant to everyone. When we substitute m0 equals 0, this formula becomes energy is proportional to, right? This one disappears. Energy is momentum multiplied by the speed of light. The reason why we use this is that the photon is moving with the speed of light, always with the speed of light. But in case we have a massive particle, then there should be a rest frame in which momentum p can be 0. In that frame, we reach E over c equals m0c, and this one gives E equals m0c squared. Rest mass multiplied by speed of light is the energy of the particle, and that is the rest energy. However, photon never stops. It is impossible to have velocity of a photon to be zero. The only possible case is the mass of the photon should be zero. So there is no rest frame of light. Therefore, except for photon or gluon, they are massless particles. Everyone else has its own rest frame. The special nature of photon is like that according to relativity. You can read it through. Now, Einstein introduced an idea. If Pc is the energy according to Einstein's theory of relativity, and here we introduce a interesting substitution. This is actually the de Broglie wavelength for matter wave. And actually, the electrons, such as elementary particles, such as electron, has wave nature. Just like what we have found for the diffractive behavior of light, matter has its own wave nature. The electron scattering shows fringes that is identical to those measured for the diffraction experiment. The scale of the wavelength is inversely proportional to the momentum. Okay, so if we combine this idea to the photon that is moving with the speed of light, substitute in here, we find it is h c over lambda. And c is lambda over period. Substitute, we find h over period. That is h times nu. Nu is the frequency of light. For convenience, this is called the Planck constant. And actually, people had indeed found this kind of proportional constant as a physical one. This h nu can also be expressed in terms of more familiar the wave-friendly expression, including 2 pi. So multiply 2 pi and divide it by period, it is an angular frequency omega. So h divided by 2 pi is called the reduced Planck constant, and we use slash, and we read it h bar. Okay, so h nu is nothing but the same as h bar omega. This h is now determined to be an exact. We decided to use an exact number. This is a fundamental constant that determines the energy scale of a photon with its wavelength. We know now know this Planck constant is a constant, and speed of light is a constant, and this is again a constant. So I missed this multiplication sign. Elementary charge, that is the magnitude of an electric charge, is now also fixed as constant. And actually, the first measurement of this H over E was the photoelectric effect. The photoelectric effect is, let's see, the intensity of photoelectrons is proportional to the intensity of the incident light once photoelectrons are being emitted. So photon, and actually they didn't know what photon was. Instead, they shed light on a metal. And then they found some electrons comes out of the surface of the matter. Okay, but they changed the light blue and ultraviolet, red, and infrared. By changing the wavelengths, they watched the emitted electron. The name of these electrons are called the photoelectrons. Emitted electrons due to the electromagnetic waves. Unfortunately, according to Maxwell's theory, we know the energy density is supplied with the speed of light, and this plus magnetic field energy, and this is actually the pointing vector. So pointing vector doesn't care about the wavelength or frequency of light. However, actual experiment shows that the photoelectron is not emitted at lower frequency. That means longer wavelength. So for example, infrared light, whatever intensity we may apply, no electron appears. However, if you shed UV light on it, bunch of electrons are being emitted. And if you pour more to increase the intensity of the UV light, then more and more electrons are coming out. Aha. So they thought that the electrons in matter have a binding energy. For example, proton and electron, they are connected by electromagnetic force, especially electrostatic force, and some light has a stronger energy to break the bondage. But basic difference in the idea is Maxwell's theory is a continuous theory for wave. The light wave can carry a lot of energy if we increase the flux. However, even though there are large amount of flux, it is impossible for a longer wavelength to emit electron. That means the flux doesn't matter, and the main crucial point is that the energy supplied by the electromagnetic field is mediated by a single quantum that is called photon. So there are many photons coming in. So although in a collective way, the electromagnetic field is actually the sum of multi-particles, and every particle has its own energy, and that energy depends on the wavelength. If the wavelength of this photon is long enough, its energy is weak, it's small, so it cannot hammer the electron to detach from this bondage. Okay, that's the basic idea. And by the time Rydberg constant was known, and Rydberg constant involves the emission of light from hydrogen atom. Hydrogen atom emits photons with a certain frequency. That means the energy of a photon is closely related to the energy levels of electrons trapped inside hydrogen atom. And without knowing the theoretical background, the expression was already known. And these are integers, 1, 2, 3, something like that. And actually, we learned a little bit about Bohr theory of hydrogen atom, and Bohr's wrong theory reproduced this energy spectrum of the discrete spectrum of the light quanta. You may be familiar with the 13.6 electron volt. That is the unit of these transitions. Anyway, supplying such kind of energy from electromagnetic wave that is greater than a certain threshold, it was possible to emit electrons from metal. You notice that there are differences. You have different values of Z, the atomic number. As atomic number increases, the electron that's coming out of the atom is detached from a longer distance. If it is small, the radius of the electron should be shorter, and you know the potential energy is proportional to 1 over r. So when r is smaller, the energy required to break the bondage with the nucleus will be very large. You can see big, small, the energy required to detach an electron, that is called the work function, increases as the size of the atom decreases. So we find the intercept of this V stop. V stop is, you should have learned the Y25 already, to stop the electrons, that photoelectrons that has been emitted from matter. We should give some electric field to decelerate the electron. So that is called the V-stop. The energy of an electron can be computed by multiplying the electric charge of an electron to V-stop. So that is similar to the kinetic energy of an electron. And that kinetic energy is to be interpreted as photons' initial energy is partially used to break the bondage of an electron. So some energy is used to break the bondage. That is called E phi, and phi is called the work function. Okay, and then from the energy of a photon subtracted by this amount, you will find the remaining energy carried by this photoelectron. Now this electron has been detached from the metal. It can be treated to be a free particle. Is in non-relativistic limit, it should be a kinetic energy, something like that. Therefore, here we find from a certain frequency, we have frequency only in the region. This is a threshold. Above the threshold in frequency or below the threshold of wavelength, photoelectrons are being emitted. Okay, so the frequencies depends on the size of atom, and it is still they have some connection. How? This phi multiplied by work function is the binding energy to break the bondage of an electron in a matter. And threshold frequency shows h nu 0 must be greater than this to have photoelectrons. So measured slope in this plot is showing the ratio h over e, the most fundamental, one of the most fundamental physical constant. Okay, now Einstein's this kind of interpretation, even though Einstein became already famous for the relativity, people were reluctant to give Nobel Prize to Einstein for his relativity. Instead, photoelectric effect is also famous achievement of Einstein. So Einstein was not awarded with the relativity, instead the photoelectric effect. Now, the relativistic four momentum idea was indirectly proved experimentally in the limit where m, rest mass m, goes to 0 for the case of this photon's momentum. But the exact comparison with the photon's momentum was not possible in this indirect experiment. Instead, explicit comparison with the experimental data was possible due to Compton's experiment. He used stronger energy. So he decreased the wavelength a lot to reach the X-ray. When X-ray is used, the binding energy of the electron can be negligible because the h nu of an X-ray is much greater than they used to study the photoelectric effect. Okay, so we again use these formulas, and we are interested in checking the free momentum. This is a spatial component of the momentum that carries the velocity dependence of mass that has not been well studied in photoelectric effect. Instead, with the very high energy photon, it hits the matter, but we can treat this electron attached to metal is a free particle, because in comparison with the large energy of an X-ray, the binding energy is very small. So we can make an approximation that electron attached to matter is a free particle, and he found this kind of scattering. Electron, photon meets, and photon is emitted. In the rest frame of an electron, electron is at rest, photon hits the electron, and then finally they travel together. It is just like a collision of billiard ball. The target is at rest, and incident one hits the target, and both of them move together, something like that. In this expression, Einstein's force momentum was used, and some of these force momentum, this one, each of them has 4 components, and the conservation formula for the force momentum is for every component of the force vector, and the energy component, the time component, the zeroth component says energy is conserved, and the remaining 3 spatial components says momentum is conserved. So this force momentum conservation was tested experimentally due to Compton, and eventually you can follow the calculation by making use of what we learned yesterday, and this relation gives, at the end of the day, wavelengths of the incident and outgoing X-ray. It slows down. The photon never slows down, but the energy is dissipated because it shares its own initial energy h nu, and this energy is smaller. It becomes smaller because it shares the energy with the electron, and the change in the wavelength of the scattered light against an electron verified this very strange idea of force momentum is completely conserved. Therefore, our starting point, the speed of light, is constant, is confirmed by Michelson, and as a direct consequence, Einstein constructed idea of a force momentum in which energy and momentum has the mass depends on the velocity, and actually it is m0 multiplied by this strange factor called the Lorentz factor is completely confirmed by experiment. So it is not a nonsense, it is a fact.